Hello everyone, this is Linda again. In this section, let's learn how to create a component system in the Unity DOS Visual Scripting 2 environment. Open the Visual Script panel. You will see there are different methods for creating graph. Graph is visualization of component system. Nodes equal to code blocks. Code is automatically generated. Let's create a folder for all the graphs code system. Right-click and create a graph file called Player Control. C# code is to be automatically created by the Visual Scripting tool in the Runtime folder. Drag the player ship from the hierarchy panel and drop it into Graph. VS2 will automatically create a query variable for us. Its parameters are components which help us find this entity in entity lists. Each of query parameters is a component that might contain data or just an empty tag. We only need to keep necessary parameters for querying the entity or for graphic use. Translation, rotation are not unique components. In order to return a series of specific query entities, we often add tag component to entity. We can also create an entity query directly on the Blackboard and drag it into the graph. Let's click on the query slot and drag it over to create event node. We use onUpdateNode stack to hold all the update functions each frame. Select the blank area of the update node, press the spacebar here. In the pop-up search panel, enter translate and add this node into the update node. Then click the button on the right to change the Flow3 input mode to Axis so that we can enter the values for each coordinate separately. Click on the chat box next to the gray text Add because we want to add input coordinates as an increment to the current translation. Right-click on the canvas, select Get Input Node, switch input mode to horizontal. Copy this node and switch input mode to vertical. We will get the X and Z direction keyboard input data. You may notice the error message at the bottom of the window. We can clear them in the console panel at any time. Connect the two nodes you just created to the X and Z inputs. Click the play button and text our scene. The play ship is flying too fast. Since the game should be greater than 500, the keyboard input will change the value of the object's coordinates allowed in a short time. Let's create a float variable named speed on Blackboard. Drag it onto the graph and create a node called delta time. We need a multiple code. We found that there are two nodes representing multiplication. They're from different namespace. They have the same functionality most of the time, but the mul node can clearly constrain the data types of our input and output, so we use a mul node at this time. Multiply delta time by speed, then multiply the result by keyboard input. We will get the fixed translate data. Assign the result to X and Z respectively. We can use Ctrl+C and Ctrl+V to copy nodes. You need to save all and build each time before running. This allows us the Visual Scripting tool to convert graph nodes to C# code in the Runtime folder. Click on the Code Viewer panel and you will see the automatically generated code. Here is the speed variable we created. We set speed value here. Here is a code line that changes the translation value. Let's set the speed to 8, slightly faster before running. Click on the play button again. Nice! The player ship is moving around, but we found that the ship often moves outside of the view. Here we need a node named clamp, which is used to constrain the X and Z coordinates we created. To make it easier for us to check if the ship is in the border area, let's set the parameters to be smaller than the background size. We insert these two nodes into the logic. Because the clamp coordinates are created with absolute coordinates, you can no longer use the add translation method. We change the translate mode to translate to mode. Drag and drop the translation variable from the onUpdate node, which represents the translation of each font entity. We use the Add node to add the original translation to keyboard input, generate a new translation, and finally pass it to the Translate node. Let's copy these nodes and work on the Z direction calculations. Don't forget to switch the coordinates value here at the z coordinates. Save all, build all, and play. The player ship does move within the designated boundary area. Isn't that cool? Okay, it's all for today. See you next video.